So here comes our final chapter, Indian Oceans. So for your information, usually we cover a few other topics, but I think for this year we try to cover only two topics, which is Pacific Ocean and Indian Oceans. There is other ocean system like Atlantic Oceans, which is also very interesting. We have Arctic Ocean and we have Southern Ocean. But for this year, I think if we only focus for these two oceans, but with this knowledge, I think you can also explore other oceans with those knowledge as well. So Indian Oceans is very interesting because this is the only ocean to compare to Atlantic and Pacific, where you only have one ocean basin. In the north, we have a huge landmass, and this landmass produce annually monsoon season, and this monsoon season change the water, the current movement in the northern part of the Indian Oceans, which make it interesting because usually in large scale ocean circulation, this current system doesn't change. It happens throughout the year, but in Indian Ocean, this is very much different. So there are a few important and very interesting features in Indian Oceans. Let's have a look at it. So the objective of this lecture will be to look at into descriptive understanding on general current circulation and its characteristics. So basically, we will look at what is the major current circulation there and how it forms in the large scale. The most important thing about this current circulation is in Indian Ocean there is what we call as a monsoon system, and monsoon system is very unique because you will not see this in other ocean system in Pacific or in Atlantic Ocean. So this monsoon system changes during two seasons, in winter and summer. And at the same time, you will look at the Agulhas retroflexion, and then later you will look at Indian Ocean dipole, how changes in the temperature of the ocean can change the atmospheric circulation and influence the precipitation and rain in the Indian Ocean. So this is three major things that we're going to look today: descriptive understanding, the monsoon system that change and influence the Indian Ocean circulation, Agulhas retroflexion, and Indian Ocean dipole. So let's have a look at the Indian Ocean setup. So this is Indian Oceans. If you look at here, Indian Ocean only has one basin, alright, because in the north it is a landmass. So so they are not it's connected to the Pacific and via Indonesia, and also Atlantic through at the bottom parts of South Africa. So the unique things about Indian Ocean is it is very much influenced, especially in the North Indian Ocean. It is influenced by the monsoon system. So we have two monsoon systems, similar to Malaysia. You have summer monsoon, and then we have a winter monsoon. So summer monsoon we call southwest monsoon. Winter monsoon is northwest monsoon. Winter monsoon will influence, high pressure area will move to the low pressure area, which is from land to oceans. So this will create rainy, almost a dry season. But the unique things about the monsoon season is it is very much wet season, lots of rain during summer monsoon, where you have this high pressure area move to the low pressure area here, and then it gives heavy rains to the subcontinent India, Bangladesh, in this area. Alright. So basically, summer monsoon is the monsoon season where you have lots of rain in the subcontinent of India. So, but the most important thing you need to remember is during this monsoon season, so you can see that wind moving in two different directions. In winter time, so wind is moving out from land to the oceans, and in summertime, wind move in from the ocean to the land. So this is what actually influenced the upper part or the northern part of ocean circulation in the Indian Ocean. So let's have a look at the surface currents in the Indian Ocean. So if you look at here in the northeast monsoon, so you have in the northern part of Indian Ocean, so you have south equatorial current, equatorial counter current, north equatorial current, and then you have this Somali current over here. So this is very much what we have in Indian Ocean current surface circulation during northeast monsoon. So but when you look at the southwest monsoon, so you don't have any more the east equatorial counter current. So you have south equatorial current, and in fact north equatorial current is moving to the west, and now it moved to the east. So, and we have another name for it, which is a south monsoon current. All right. So if you look at here, there is no like a gyre circulation. So it's just a very proper gyre circulation here, and then you have one circulation here. But in the south of monsoon, you have like a small gyre circulation here. So south equatorial current, Somali current also changed from moving south, and now it's moving north, and then south west monsoon current, and it continues. So you have like a small gyre here, and then the big gyre over here. Of course, you have West Australia current here. Air current, which is they name it as a Lewin current. So this is a very unique current system that you have in Australia, which is very close to the coast. Alright, so now you can see there's two major differences between northeast monsoon and southwest monsoon that creates this current system in Indian Ocean. So this is what you need to remember. So monsoon winds change the northern part of Indian Ocean currents from so especially the Somali current and the southwest monsoon current, and then so this is the two major things that you should be able to describe how this current system changes because of monsoon, because you don't see these changes in the large gyre system like in Atlantic or in Pacific. So this is very unique in Indian Ocean. So let's have a look at the Aguilas current. So one of the unique characteristics of the current system in the Indian Ocean. So we don't go into every single current system in Indian Ocean. So we just choose one. So we look at the characteristics and have some descriptive understanding about it. So Aguilas current is waters coming from along the Africa, the eastern sides of Africa to the South Africa part. So if you look at here, it's very unique. So you have the south flowing current, and suddenly the current flows back into the Indian Oceans. So when they meet at the bottom parts between Atlantic and Indian Oceans. So the Aguilas current is coming from the western boundary current, which is here. So it flows from the east coast Africa north to the south, and the strength is different between summer and winter. So you have maximum during summer and minimum during winter. So it shows that during summer, somehow the monsoon create a much stronger current system in Aguilas. But what is unique about this current is what they call as Aguilas retroflexion. Aguilas retroflexion is the return current flows eastward that shows the meandering patterns with a wavelength of almost 500 kilometers. So this is very unique. So you don't see much of this kind of current other than Gulf Stream in the north of Atlantic Ocean. So if you look at here, so this is the temperature of the current. So you can see characteristics are very defined. So as you go south, and then it meets with Antarctic circumpolar current at the south. So that's why it return back, and they call it as a retroflexion. And this retroflexion can be seen from the satellite images. So scientists are very interested with the retroflexion because you can see how productivities form in these waters. So for instance, you can see this is chlorophyll data. So you can see chlorophyll data is representing a productivity of waters. So high productivities along these meanders. This is very unique. So you can see from this flow of satellite images how this water's flowing like kalau dalam bahasa Melayu kita kata macam ular kena palu. So this is how it looks like. So it's very simple and straightforward, but it's very interesting because scientists look at it in different ways, because they try to understand how productivity influenced by it, how the current and the dynamics form into such a very unique movement. And now let's have a look at the interannual variability. So interannual variability, in this case, we call it Indian Ocean dipole. Indian Ocean dipole is a unique characteristic, happens only in Indian Oceans. That's why we call it Indian Ocean dipole, because of a difference of sea surface temperature between west and east of Indian Ocean. So when you have this imbalance of temperature in the oceans. So it also creates imbalance in the atmosphere. When it creates imbalance at the atmosphere, so it will cause some disturbance where, you know, rainfall or droughts will happens in this scenario. So there is two types of Indian Ocean dipole, which we going to learn later. Which is, one is positive Indian Ocean dipole. We call positive phase and negative phase of Indian Ocean dipole. Alright, so it's similar to El Nino. So if you heard about it, so we're going to learn about El Nino in Pacific Oceans. And the IOD first identified in 1999, but scientists believe that it happens, you know, many times in the past. But we cannot actually define when it's going to happen. So we only know about it when we study the ocean data and, you know, understand what actually happens at particular times. Then we can estimate and predict what's going to happen. So scientists don't actually know why it happens in the first place, but we can, once it happens, we can almost predict what's going to happen with the weather. So for instance, the positive Indian Ocean dipole. So we have a warm weather in the western side. So when you have warm weather, a warm pool of water in the ocean, so it creates lots of evaporation and precipitations. All right. So again, so this is a very cool. So we don't say it's not cold, but it's cooler than the western side. So this air tend to move to the left or to the west, and then creates an area with lots of rain. So what happen is, this area will be much drier, less rain in the area, especially in the Australian part. Okay. So what happened in the negative dipole? Negative dipole is opposite. So you have a very warm pool of water in the east and cool pool of water in the west. So warm area tend to have more precipitations than the west. So what happened in the African side, they start to have a drier climate during those dipole. And you can see that Malaysia area, the Southeast Asia and Australia tend to have more rain during this period of time. So this is what dipole do. So the negative and positive Indian Ocean dipole is when you have this imbalance between western and eastern sides of Indian Ocean. So, and it creates a drier area and a wet area. So it depends. So again, if I can recap, so the positive Indian Ocean dipole will tend to make our region much drier than the western part, while the negative dipole mode will tend to make Africa side much drier than the Southeast Asia and Australia part. Alright, so if you can see, this is the kind of actually mechanism why it happens. So when you have a very high temperature water here, so it increases rainfall, and also the wind tend to move away from the low pressure area. Alright, so and when this wind move away, so it will bring all those moist water air into the Africa region and Indian region, so makes this area much drier. Okay, so the significant positive IOD happens in 97-98 and also in 2006, so which makes it very dry. So 97 and 98, if you can remember, so this is the most extreme El Nino happens in our region, which also bring dry weather. So I think scientists start to realize that this El Nino become much drier because it coincides with IOD during that particular time. So I think the best example is Australia. So IOD is quite new among scientists, so it's still very limited amounts of information that we can get about IOD. But I think in Australia they start to make this study very much important, because it affects Australia very much in terms of climate. So during positive IOD, Australia happens to have a very bad weather, bad in the sense that it gets very dry. They have very little amounts of rainfall, and they have problem with water sources. So that's why they put up lots of study here. So this is an Australia example. So if you look at here, So they try to imagine this system as a cell system. So if you remember Hadley cell, Farrow cell that we talked earlier when we study about atmospheric circulation. So this is a cell system that happens during IOD. So this is normal condition. So during normal condition, you have this kind of cell system bringing moist air to the Southeast Asia and Australia region and bringing rainfall. But what happened during positive IOD? So this cell system shifts. So it brings moist air to the west and then bring convection and rainfall to the western part of Indian Ocean. So it flips, it goes in the opposite direction. So it creates a reduced area with a reduced chance of rain. But it is also unique that even though you have less rain here, but you start to see upwelling increase, which means productivity increase during this period of time. So this is the unique things about nature. So when you think that you get less, but instead you have something else happens in those areas. And negative Indian Ocean dipoles, in fact, it goes back to the normal cell condition, but it brings more rain and much wetter area during the negative Indian Ocean dipoles. So there you are. So this is some examples on how Indian Ocean is quite unique in the sense. So each ocean basin have their own uniqueness. So this is what you have in Indian Ocean. So you understand that a monsoon system influence the current circulation here and change during those two seasons between summer and winter. And then we look at Agulhas retroflexion, and at the same time we look at interannual variabilities, which is changes in interannual period time scale in the aspect of Indian Ocean dipole. So I hope that you can get these three major important things about Indian Ocean and be able to explain based on those understanding. Alhamdulillah. So that's all that we have learned for physical oceanography. I think you gained lots of new knowledge about physical characteristics, current circulations, oceanographic features. That is very interesting, and you understand the dynamics, how these features happens, and you will apply most of this knowledge in other topics of other subjects of oceanography. I hope you gain lots of new knowledge and you appreciate this knowledge, and I hope you can apply this knowledge throughout your studies and of course throughout your career later on. So good luck for your assignment and final exam. So I wish you all the best. Assalamualaikum.